Okay, Unit 3, Day 4 notes. The HL theorem and non-congruence. So, we're going to have a new way to prove angles congruent, HL. So, if the hypotenuse and the leg of one right triangle, and that's key, it's got to be a right triangle to even have a hypotenuse. Because the hypotenuse is the longest side of a right triangle. So if the hypotenuse in one of the legs is congruent to the same parts on another triangle, then they are congruent. And as it says, only right triangles. So with right triangles, the theorem says if the hypotenuse and leg of one triangle is congruent to the hypotenuse and leg of another one, they are congruent. So here, the 90 degrees tells us we have a right triangle. The hypotenuse is 5, and this leg is 3. Therefore, these two triangles are congruent by the HL theorem. For example, we have right triangles. The hypotenuse, remember, is always opposite. So it's not just that both triangles have a 1 mark and a 2 mark. This is the hypotenuse. These marks mean the hypotenuse are equal. And then, even though it doesn't look like it because these are rotated or flipped or whatnot, we have a leg that is marked congruent. Therefore, we have congruency by HL. So let's see if these are congruent, yes or no. Then we're going to write a statement. So we have our right triangle and our hypotenuse. We have a right triangle and our hypotenuse. Both of the hypotenuse are marked with a 2 mark. We have a leg here marked equal, so we have a hypotenuse and a leg. Now we just need to make our statement. And we can start wherever we want. We start at the C and say triangle C. Maybe go down to the right angle, PA. Is congruent to, we're going to start at the same place, triangle B down to the O, the right angle, and W. So we're saying they are congruent, and then we just say, again, our justification is by HL. Okay, well, on this one, wash, we have a right angle here. Since ASH is a line segment, this is also a right angle because right angles are supplementary to each other. Here's our hypotenuse. Here's our hypotenuse. They are marked equal to each other. And in the middle, we have a leg, which we talked about is equal to itself. Remember, we could cut that triangle just like this, A, S, W, and H, S, W. And these would obviously be equal to each other. And we already have the hypotenuse on each one marked, and we know these are 90 degrees. So that's what it would look like if we cut it apart. So, do we have a hypotenuse and a leg? Yes, we do. So I'm going to say a triangle W. Well, no, not a W. W out to A, and then come into the right triangle. We could say WSA. It doesn't matter, as long as you're consistent on both of them. It's congruent to triangle, starting at the W again, out to the H, back into the S. And then we say by HL. Examples. Are these triangles congruent using HL? If not, why not? Well, we have a right angle and we have a right angle. Here we know these are equal to each other. Doesn't really matter for this rule for HL, but we're just reminding ourselves those are vertical angles. We have the hypotenuse marked the same on each of them. That's hypotenuse, that's hypotenuse. But we have a hypotenuse and we have an angle. and a 90-degree angle. But we have no rule for that. Now, we're not trying to prove this by, A, S. We're not doing that. We're asking whether or not we can prove it by HL. And the answer is not possible. And it's because there is a leg missing. Okay? We need to have this leg or this leg marked on both of them congruent to each other. Since we do not have that, we cannot prove it by HL. We might be able to use another rule, but not HL. And that's what it's asking. Well, remember we have a triangle like this, any kind of drawing, this shape, this line is going to be equal to itself. Since we have a 90-degree here, we have a 90-degree here. That's our hypotenuse, that's our hypotenuse. They are marked equal to each other. This leg is marked equal to itself. Again, that is like if we cut them apart, 90, 90, equal to each other, hypotenuse equal. So yes, we do have congruent triangles. We can't make a statement because we have no letters, but yes, we can prove it by HL. Do we have an AAA theorem? So we're going to draw two rays connected by a 30-degree angle. At the end point, we're going to draw a 60-degree angle and connect the two endpoints. What's the measure of your third angle? How does the size of your triangle compare to the student's triangles on either side of you? So we're not going to do this, obviously. We'll play with this in class. Is your triangle congruent to the other student's triangles? So this is something we'll do in class before we start the next lesson. But it's a fun little activity to compare ideas and see if we have this rule. So we'll talk about that. Do we have an SSA theorem? Okay, so the link wasn't exactly working, but this is the page you can see up here. That's the page it was referencing. You can go to this if you like to play with it. But here's why SSA doesn't work. So over here on the left, we have a triangle, and this angle here is marked the same as this. Let's say it's 25 degrees. Could be 30, 27, whatever. Notice we have this leg is equal to this leg. And this leg is equal to this leg. But wait a minute. Notice I can take R and pull it in this way until this length is exactly the same. I still have a triangle. So notice, I have two sides and an angle, a non-included angle. But I cannot call them equal because even though they are equal here, it can be manipulated there. And so you have two sides and an angle, but that does not prove necessarily that they will be congruent. They can be, they may be, but there's nothing saying that they will always be. And that's what the theorem proves. It will always work. There are no exceptions. And this one would have an exception. Plus, SSA spelled backwards, we can't have that rule. So, last example, are they congruent? If not, why not? So, just go ahead and go around with your letters. We have an angle here, angle here. We have an angle here, and an angle here. They're all matching. Okay? So there's angle, angle, angle. But what you'll see, we'll talk about this after we do, the answer is no. They're not necessarily, they may be congruent, but not necessarily. Okay? And we'll talk about why not after we do the activity in class. Let's see what we have here. We know this side is equal to itself. So we have an angle here, we have a side here, and a side here. Angle here, side here, side here. Well, the video I just showed you shows you that we do not have an SSA or an ASS rule. It does not work because I could pull, let's say, this line in to be over here and be the same length, but definitely not the same triangle. And that's it.